Hello and welcome to another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 11, Lesson 4 on measuring the center of a data set. Again, this unit is all about answering statistical questions, right? Questions that involve variability. And there's probably no topic within statistics that is more used and more important than the center of a data set, right? And you'll hear this all the time. In fact, most often when somebody gives an initial answer to a statistical question, it will be with the use of a center measure, a measure of center. So if I'm going to keep coming back to how much money do lawyers make? Well, somebody might immediately say to you, well, on average, they make $120,000 a year. That on average is a measure of the center. All right, so we're going to talk about three measures of center today, the three most common measures of center, all right, and kind of what affects them and how to calculate them, et cetera, et cetera. So let's get into them right away. When answering a statistical question, we often refer to one of the centers of the data set. A center is a value that is representative of all the values in a set, right? Or of a typical value in the set. The most common measure of center is called the mean, which you oftentimes just call the average. Why is it called the mean? Well, really, it's because there's many different types of averages and many different types of means. So what we do is we give it this special name, but I never want you to forget, especially if you already feel comfortable with what the average of a bunch of numbers is, the mean is just the average. So let's take a look at it. The mean of a data set, aka also known as the average. The mean of a data set is found by summing all the data values, adding them all up, and then dividing by the number of values in the data set. So if I had 7 data points, I would add them all up and divide by 7 in order to find the mean, also known as the average. In fact, let's take a look at exactly that scenario in exercise number 1. The high temperatures for the last week of April in Red Hook are shown below. Find the mean temperature for this week. Show your work. All right, so basically at the end of the day, right, what we need to do to find the mean temperature is we need to add up all these temperatures and then divide by how many temperatures there are. There are 7 of them, right? Remember how we use that n equals for the number of data points? N equals 7, all right? And now we want to add them all up, divide by 7, and see what we get. All right, so let's do that. Now I find adding numbers a lot easier if I've kind of got them stacked vertically. So I'm going to have 59, 61, 67, 60, 57, 65, and 72. All right, so I just need to add all of these up. Simple enough. Let's talk about it, right? So what we've got is we've got 5 plus 2, which is 7. Plus another 7 is 14, plus another 7 is 21, plus another 1 is 22, plus 9 is 31. All right, then we have 7 plus 6, which is 13, plus 5, which is 18, plus 6, which is 24, plus 6, which is 30, plus 6, which is 36, plus 5, which is 41, plus 3, which is 44. So I would call this the sum, right? The sum is equal to 441. All right, now to find the mean, or the average, right, we're now going to take 441, and we're going to divide by how many there are. There's 7 of them. So, okay, 7 goes into 44 6 times. That gives me 42. I do some subtracting. I get 21. 7 goes into 21 3 times. And I get a mean of 63, right? So if we were trying to answer the statistical question, how warm was it in the last week of April in Red Hook, right? Well, that's a statistical question because there's a variation in how warm it was, but one good answer to that question would be, well, on average, it was 63 degrees as a high, right? Now, if I notice, by the way, that the smallest temperature in here is 57, and the largest temperature in here is 72, okay? If I had made some kind of understandable arithmetic mistake, and I had gotten an average, a mean, that was either smaller than the lowest value or greater than the highest value, that wouldn't make any sense, right? The idea is the mean is supposed to be a number that's kind of in the middle of the data set and generally represents a typical value of the data set. All right? So easy enough though, right? It's a simple idea. Add them all up and divide by how many there are. Now, one thing I want to make sure of is that you kind of have a good sense of what the mean really tells us. Let's take a look at that in exercise number 2. Kevin and his 2 friends compare the amount of tickets they have each won at an arcade. The 3 values are 62, 79, and 84. Letter A, find the average number of tickets the friends have. Show your work. All right, well, I'd like you to go ahead and do that, right? You're going to add up all 3 of them and divide by 3. See what you get as the average number of tickets that they won. All right, simple enough. Let's do it. Let's stack them. 62, 79, 84. All right, I'm going to do 4 plus 9, 13, plus another 2, 15, carry my 1. 8 and 7 is 15, plus 6 is 21, plus another 1 is 22. So the sum of all their tickets is 225. I'm going to now do 225, and I'm going to divide by 3, 7, 21, 15, 5, another 15, subtract 0. So the mean equals 75. All right. So on average, right, they won 75 tickets. All right. Now let's take a look at letter B. The boys decide to share their tickets with one another so that each has the same number. How many do each have? All right, well, pause the video. This is kind of a simple sort of 3rd grade sort of problem. Hey, each person has this much of whatever, but they want to now, divide them up evenly between the 3. So pause the video now and see how many each would have if they threw all their tickets together. You know how you get the game, you get like toys at the end of like being at an arcade or something like that, right? So they want to be cool with each other and, share the tickets. So they're going to toss them all into a pot and divide them up so they each have the same number. In letter B, try to figure out how many each has. Well, I hope you got 75, right? Because how would you go about doing this? Well, you would add up all the tickets that they have collectively, right, which would be 225. You'd then divide them up amongst the 3 people that are there, and each person would get 75. Right? And that's really what the average tells you. And what I mean by that is literally, it's sort of like if you took all the data and you threw it into a big box, and then you divided it out evenly so that each data value was the same, that's what the mean would be. Right? So in other words, on average, these guys have 75 tickets each. And that's exactly what they'd have each if they shared the tickets between themselves. That's what the mean tells you. It's sort of like if all the data values were the same and gave you the same total, what would the data value be? It'd be 75 in this case. Now, one of the really important things about means that can confuse students, we're going to get at in exercise 3. So let's take a look at that. Does the average of a data set, the mean, have to be one of the numbers in the data set? Explain or justify your answer. All right, so a lot of times people get confused about this exact issue. What I'd like you to do is look actually both at exercise 2 and at exercise 1. Does the mean have to be one of the data values? Pause the video now and see what you think. Absolutely not. Absolutely not, right? So I'm going to just put big emphatic no, maybe with some exclamation marks as well, right? And again, we don't even have to look at the first exercise, although we could. We can simply look at this exercise. Right? The mean is 75, but the 3 values were 62, 79, and 84. Likewise, we can go back one screen, right? When we were looking at those average temperatures, the average temperature was 63, and yet you don't find a 63 anywhere in there, right? There's absolutely no reason why the mean has to be one of the data values. It certainly doesn't. You know, and again, you can see it by just pure example, right? Nope. In fact, let me say in neither exercise number 1 or number 2 was the mean part of the data set. Now, let's be very clear. It could be. It certainly could be. You know, there's no reason why one of these couldn't have been 75. It just wasn't. But a lot of times, because we say things like, you know, the mean represents a typical value of the data set or a center value of the data set, it seems like the mean actually has to be one of the data values. But it doesn't, right? It is simply the result of adding all the data together and then dividing by how many data values there are. That is simply a calculation. It gives you a number. It should be a number that would fall within the range of the data set, but it doesn't have to be one of the values in the data set. All right, let's take a look at another very common measure of center. Now, the mean is critically important. You talk about averages all the time, but another common measure of the center is what's known as the median of the data set. Now, the median of the data set is sometimes also known as literally the middle of the data set. The median of a data set is found by finding the middle number of the data set if it has an odd number of values, all right? So if I arrange all the values of a data set in numerical order, in ascending or descending order, going up or going down, the number that's right in the middle, that's the median of a data set. Now, one thing that's tricky about the median of the data set is if there is an odd number of data values, like 5, 7, well, you know what odd numbers are, 21, right? If you have an odd number of data values, then there is one number that is literally right in the middle of the data set. On the other hand, if you have an even number of values, there isn't. In which case, what you do is you take the two numbers that are most in the middle and you find their average, okay? You find their mean. All right, and that then gives you, in theory, the number that would be right in the middle of the data set. So let's take a look at how one finds the median, the middle number, in both of those cases. Let's take a look at exercise number 4. Each of the following data sets has been arranged in order from the lowest to the highest, called ascending order. State the value of the median. Show how you found your answer. All right, so the first thing you always want to do when you find the median, in my humble opinion, is know how many data values are in the data set. So in this first one, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 data values. Now, one technique that some students like to do, all right, when they find the median, is they literally like to just start from the two ends and kind of work their way in until they find the middle number. And because we have an odd number of numbers here, there will be one right in the middle. But you could literally say, okay, 4 and 25, right? And then you could do 7 and 22, and then 11 and 20, and 14 and 18, and that means that the 17 is right in the middle, right? So you could literally just go, doot, 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 doot. Boom, there's the middle number. Another way to do it when you've got an odd number, right? And I know this is going to sound weird. Notice that there are 4 that I've crossed out here and 4 that I've crossed out there, right? So one way to sort of kind of circumvent going 1 is by taking your odd number, subtracting 1 from it, right? Now if you take an odd and you subtract 1, you're going to get an even, all right? And then if you take that even number and you divide by 2, it'll tell you how many will be on each side of the median. There's going to be 4 below the median and 4 above the median, and therefore the median will be the 5th value, right? So it kind of can help tell you which value will be the median. And I'll use this approach again a little bit later on and in future problems. So the median, let's just be clear about this since I never formally wrote it, I just circled it. The median in this problem is 17. That is the number right in the middle. Now let's take a look at one where we have an even number of data points. Right here I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10 data values. And in this case, I will always just do this to tell me kind of, all right, where am I, right? I've got 5 and 5, right? So 1, 2, 3, 4, 5, right? And 1, 2, 3, 4, 5. So the median in theory would lie right in the middle of 22 and 26. And that really kind of gets at the heart of it. I want the number that's right in the middle of 22 and 26. And the way that you find that is either by just thinking about it and thinking about, all right, well, I got 22 and 26, what would be the number right in the middle of it? Or I simply find their average. In other words, I take these two numbers and I add them together, right? And I get 48. And then I take 48 and I divide it by 2 and I get 24. So the median in this case is 24. And by the way, going back to that issue we talked about in the last exercise where the mean doesn't have to be part of the data set, well, if there's an odd number of values in your data set, then your median is definitely one of the values. And if you have an even number of data points in your data set, the median could be part of the data set or not, right? There is no 24 in our data set. Now the median, again, is a fantastic measure of the center because it literally lies at the center of a data set, okay? And you will sometimes hear people say like, well, how much money does a typical US household make per year? Great statistical question. You know, how much money does a US household, a family, let's say of 4 people, bring in each year? And you might hear, you know, somebody from government or someone important, not me, you know, you might hear them say something like, well, the median household income is $57,000 a year, you know, or something like that. And they'll oftentimes use the median and not the mean in that case. And we'll eventually be talking about why one might use one of those measures instead of the other. For right now, and in this lesson, we just want to concentrate on how we find them, all right? So let's do a little bit more work with mean and median. Now the median and the mean values of a data set are rarely the same number. They can be, but they are rarely the same. They're often, though, close to each other. And when they're not close to each other, that's when there's something interesting going on. All right, now what does it mean to be close to each other? Well, that takes a little bit of nuance, a little bit of practice, and a lot of work with statistics. But let's take a look at that issue in exercise number 5. Camilla asked 5 of her friends how often they rode the subway this week. She recorded the following observations. All right, so a nice small data set, all right. Letter A asks us for the median of the data set, what we just worked with, and letter B asks us for the mean of the data set, right, what we began with. So since we've worked with both of these at this point, I'd like you to do a little self-assessment, whether you're at home or in the classroom with your teacher, and I'd like you to pause the video, try to come up with the median of this data set, the mean of the data set, and then let's compare. Well, the median's a piece of cake, right? The median, remember, is the middle number. And with only 5 data points, that's pretty easy to see, right? Very easy to see that 6 is my median, right? There are 2 values that are above the 6, above the 6. There's 2 values that are below the 6. The 6 is your median. Now your mean always takes more work. There's no getting around it. The median is an issue of basically going, there it is. The mean is always, oh, I got to add these numbers up, then I got to divide by how many there are. Let's add them up kind of like nicely horizontal here, right? I got 3 plus 5, which is 8, plus another 6, which is 14, plus 9 is 23, plus 12 is 35, right? So the sum of this data is 35. And remember, these are how many times they rode on the subway. So the mean is going to be 35 divided by 5, and that's 7, right? And notice they are pretty close, right? We've got a median of 6, a mean of 7. So if Camilla was trying to answer the statistical question, how many times do my friends ride the subway? She could say, well, you know, on average they ride it 7 times, but the median number of times they rode was 6, you know. Given that those two are so close together, they both are pretty representative of the center of this data set. right? Or at least as a measure of the center. Again, oftentimes the mean and the median are close together. Sometimes they're exactly the same number. It's rare, but they can be. And sometimes they're quite different. And we'll look at that in a future lesson. But let's take a look at one last problem. We now have three measures of the center. We have the median and the mean, which we looked at in this lesson. And then we also looked at the mode in the first lesson that we had on statistics. And remember, the mode is simply the data value that shows up the most often. Let me kind of write that down just so that you remember. Right, that's the one that shows up the most often. Ironically, it's actually the measure of center that is used the least often. Right? And again, you could imagine why, right? If I said something like, if I was trying to answer that statistical question, how much money do lawyers make, right? I mean, those salaries are going to be all over the board. There's probably going to be very few lawyers that make exactly the same amount of money as other lawyers, right? So even though there might be a mode salary, it's not going to be very useful, right? Typically, modes are not used as much as means and medians. But in a small data set like this, it might make some sense. So let's take a look at exercise number 6. A group of 8 people at a movie theater were asked their ages. The data is below. Find the median, the mean, and the mode for this data set. Are any of them the same? All right, awesome. Well, go ahead and do that. It's going to take you a little bit of time, especially the mean, all right? The median, hopefully, and the mode will be pretty quick for you, but pause the video now and take as much time as you need. All right, I'm going for the easy ones first. All right, let me do the median first. Okay, it's a little bit tricky, right? Because we've got 8 people, all right? Which means that we've got 4 of them, right? There's where my median would lie, because we've got 4 of them below the median and 4 of them above the median, which means in order to calculate the median, I actually have to find the average of 12 and 18 by adding them together and dividing by 2. It's going to be 30 divided by 2, and that's going to be 15. All right. So that's going to be our median. Simple enough. Our mode is very easy because we have very, very few data points. It's easy to scan this and say, well, the only one that showed up even more than once was 22. So that's our mode, right? Our mode is 22, right? And now for the one that's more challenging, right? The mean, okay? Because this one, we've got to add up all of these data values and then divide by how many there are. I'm going to do this, I'm going to go vertical again. I'm going to come over here to my sideboard and write these things down so that I can sum them all up. Let me get them all here, 8 and 7. All right, let's do it. We got 8 plus 7 is 15, plus 2 is 17, plus 8 is 25, plus 1 is 26, 28, 30. Right? 3, 5, 7, 9, 10, 11, 12. We've got 120 as our sum. We're going to divide that by 8. 8 goes in there one time. And 5. So our mean is also 15. And yeah, the mean and the mode, or the mean and the median. The mean is equal to the median, right? Are either one of them the same? You bet. In this rare of all cases, the mean and the median are the same number. And again, that certainly can happen, right? As it did in this problem, but it's almost more of an arithmetic coincidence when it does, because think about it, adding all of these up and dividing by how many there are gave us 15, okay? Adding these two together and dividing by 2 also gave us 15. And again, if you then wanted to answer that statistical question, right, how old were the people that watched this movie, assuming that this sample is representative of the population, you could say, well, on average, they were 15 years old, right? 15 would be a nice number to describe the central number of this. By the way, the mode would be quite misleading. Right? You could say, well, there were more 22-year-olds watching this movie than anyone else. But really, there was only one additional 22-year-old. So the mode would be kind of more questionable in terms of answering the statistical question, how old are people that watch this movie? Anyway, let's wrap this thing up, right? Measures of center are really, really important in statistics because they are sort of our first tool, especially after just kind of graphical displays like dot plots and histograms. They're our first tool in terms of how we answer a statistical question. Well, on average, kids got a 72 on this test, right? If I was a teacher and I gave a big math test and I wanted to answer the question, how well did my students do on this test? The first thing I'd want to find out was their mean score and their median score. I might even want to know their mode score, right? But keep in mind, the mean is found by adding up every one of the data values, dividing by how many there are, thus giving us the mean, also known as the average. The median, on the other hand, is always found by taking all the data values, arranging them in either ascending or descending order, and finding that number right in the middle. That can be a little bit of a challenge if there's an even number of data points, because then there's two numbers right in the middle. But then all I have to do is take those two numbers, find their average, and that's the median. We'll work a lot more with means and medians as we move forward, and a little bit more with the mode as well. For now, I just want to thank you for joining me for another NGen Math 6 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.